All right, in this final segment of Section 8, we'll be discussing the simple regression analysis using the Springdale Shoppers Survey. In this survey, respondents were asked to respond to several questions, and I'll bring in the data set here. The first question was, what is your attitude? Second is, how do you feel is this mall a family friendly? Number three, does it have adequate variety? Is it convenient? And then finally, they asked the gender of the respondents. And there's more information in this survey, but that's all that I've included in this. So what we're going to do now is show you in Excel how we can calculate a regression and the output that is created. There are certain parts of that output that are more important than others, especially for this class. We're going to be using the data analysis tool like we have before. And in the data analysis tool, you'll find one of those tools called regression. In the regression analysis, we need to define a y range. This y range is the dependent variable, or the variable that we want to predict. In this case, we're going to define the y variable as the attitude. So that's kind of what we want to predict, is the attitude of those shopping at the mall. The independent variable, or the x range, we're going to use the variable take-fam. So you notice that we captured all of the observations, including the labels. So we need to make sure we click on labels in our regression output. And then we're not going to click on anything else. We're going to allow this output to go to a new worksheet. So this is the summary output that is created in Excel. The parts that we're going to focus on in this discussion in this segment are the R squared and the adjusted R squared. We'll talk briefly about this output number called significance F, but we'll focus primarily on our coefficients, and then we'll be using the hypothesis testing language to discuss the statistical significance of those coefficients. Now I have the output here in your notes, and you can see that it's identical. If it's not identical, it's very close. I'm looking at both of them, and I think it's identical to what we've just seen. Let's start with the top box, the regression statistics. So one of the things that we want to know is how well the dependent variable is described by the independent variable, or how well we can predict the dependent variable from the independent variables. This output is given as the R squared. This is generally of no value in the regression output, but it tells us something about that predictive power. The R squared is, the R squared is a value in this. It is the proportion of the y, or dependent variable, attitude, or the variation in y, that is explained by the variation in your x, or independent variable, which in this case is take-fam. It is measured by taking the ratio of the error variance to the total variance. So it's how much of that variance in my observations am I removing by putting this kind of best fit line through the data. Note that the R squared does not mean the percentage of y that we can predict. This is merely indicating that the variance of y that is explained by the regression line. So in this case, our R squared is 0.012. That's 1.2% of the variance in y that can be explained by the variance in x. So there's more than 98% of the variance that we can't explain. The adjusted R squared is the value of the multiple R squared adjusted for the number of predictor variables. Now the equation that I represent here isn't as important as kind of understanding the concept. As I add variables to this equation, which we will do in multiple regression in the next section, I can add a lot of things that will maybe increase the R-squared but won't necessarily have predictive power. The adjusted R-squared will actually penalize me. It will come down as I add variables that are not significant. That will become more important as we get into multiple linear regression. Let's look at the next section. So the first section is this Anova section. Anova stands for an analysis of variance. We'll discuss it in general, but won't cover the analysis of variance in this class. It is discussed, however, in your notes. Note for now that the p-value, or significance f, in this case it is 11, let me get my pen, 0.115. Now we compare the significance f to the alpha, or the probability of making a type 1 error. This 0.115 is not the same as the p-value for the t-statistic of the slope in the table below. It is the same, but it won't be the same when we do multiple regressions. So what we can say here is that the dependent variable, or variables, have a significant predictive ability because the significant f value is less than alpha. The probability of this model happening from random chance is less than our alpha. Well, I got to take that back. It's not less than our alpha, so we would actually say that the predictive ability is not statistically significant. We'll see as we add other variables in the next section that it will become statistically significant. The most important part that I want to emphasize in this output are the coefficients. The first coefficient is the intercept. We assume that the intercept is 0. We start with the null hypothesis that the intercept is 0. We can reject that null hypothesis because our t-statistic is greater than 2, in fact much greater than 2, and our p-value is much less than our alpha. So we could say that 3.95 is 37 standard errors away from 0. So we can say that there's a statistically significant, and in this case positive, y-intercept. The next coefficient is the slope for the line. Now that's a pretty small slope. It means that for every unit in take fam, so how I feel about the characteristic of take fam, if it increases by 1 unit, that on average the attitude will increase by 0.036 units. Now that's pretty small, and we can see that it is not statistically significant. The t-statistic is less than 2. That's kind of our 95% confidence interval critical value. And the p-value, like the f significance f, is greater than our alpha. So you would say that even though this has a positive slope, we can't say that this slope is something other than 0. There really isn't a relationship between the variable take fam and the variable attitude. So these are the important variables and things that we're going to be talking about. It's just a start. This really becomes more interesting as we move into the next section, multiple linear regression, and we start to see not just the relationship between one independent variable and a dependent variable, but we can look at the combination effects of many independent variables on a dependent variable, and then we can start to predict that dependent variable, and we can get that prediction accuracy pretty high depending on the data that we have to work with.